Hi there. Are you unvaccinated and trying to get vaccinated to protect yourself against COVID-19 but unsure of what vaccination to get? Call 1-800-666-4845 today to take a BuzzFeed quiz to find out which vaccine you should get based on your favorite dessert. Get a free vaccination counseling session after paying for your first vaccination for twice the price at just $899.99. Okay, so there's multiple vaccines, right? If you're privileged enough to have the choice and be eligible for different vaccines, or just want to make sense of the different news articles screaming, the savior of the pandemic, not to worry, I'm here today to give you a full rundown of the differences between the COVID-19 vaccines. Of the different types of vaccines within the pharmaceutical industry, there are 4 categories that the COVID-19 vaccines fall into: messenger RNA vaccines, viral vector vaccines, inactivated virus vaccines, and protein subunit vaccines. First up, we got the mRNA vaccines, which are Moderna and Pfizer. I actually made a whole video covering their scientific process. Go check it out here. But here's the summary. The vaccine delivers the instructions, aka the mRNA, for the body's cells to build a portion of the coronavirus, namely the spike protein, like a take-home IKEA. But these instructions are screwed up. You know, like a part-time intern took the script and took the line that coded for the sharp spiky bit and replaced it with code that created a Nerf gun dart instead. So the spike protein turns out wonky and harmless. But your immune system, especially 2 types of cells called T lymphocytes and B lymphocytes, still sees the threat and cranks into gear and makes Y-shaped pieces called antibodies that propel themselves at anything that looks like the virus, locks into place, and signals for them to be destroyed by your immune system cells. Pretty metal. You may be thinking, if they're both mRNA vaccines, what's the difference between the two? It's true that they're both pieces of mRNA surrounded by lipid nanoparticles. Lipid means fat, and nano means tiny, so it's a tiny fat particle. This is useful because 1, it protects the mRNA, and 2, your cells are also coated in this same fat substance called phospholipids, so it allows the tiny fat particle to fuse with your cell membranes. So the mRNA can wriggle its way into an awaiting ribosome to get translated into a mutated spike protein. Although both mRNAs contain instructions for making the spike protein of the coronavirus, they differ in terms of how the scientists have tinkered with the protein and the specific lipids in the coating. These are the lipids in Pfizer, and these are the lipids in Moderna. Yeah, I'm not gonna unpack all that. But the point is, the main difference between their storage results from the different lipids used, because they have different temperatures at which they are stable. You know, like how at room temperature, olive oil is liquid, but butter is solid. The Pfizer vaccine needs to be stored at minus 75 degrees Celsius, and only lasts in the refrigerator for 5 days before it expires. Moderna's vaccine is stored at minus 20 degrees Celsius, but it can stay in the refrigerator for 30 days before it expires. Beyond that, they also have different dosages and age restrictions. This means you can't just get 1 shot of Moderna and be like, oh, let me get my second shot from Pfizer so I can be doubly protected. Please don't do that. Not safe. Next, viral vector vaccines. You may remember vectors from your math or physics class, and if you don't worry. I don't either, and it has nothing to do with what vector means in this context. A vector in bioengineering is something that encloses and delivers re-engineered genetic material to an organism in an attempt to introduce a new gene to that organism. Essentially, it's doing the same job as our friend tiny fat particle is doing in mRNA vaccines, carrying some genetic material that contains instructions for the modified harmless spike protein. But instead of a fatty coating, it uses a virus shell instead. But doesn't that mean it's just a virus then? No, not true. Because this virus coating isn't the coronavirus coating. It's a shell derived from a different type of virus, under a group called adenoviruses. These are particularly good at getting genetic material into cells, which is why scientists have chosen to modify it so it doesn't harm the body, but still delivers genetic information to our cells. Think of it like someone who used to rob your house, but then became a pizza delivery guy, and now you see Chuck, Bob, or Frank every Friday night when he rolls up to your porch with some Uber Eats. It's a similar order of business once the virus coating delivers the genetic information into the cell. Cell takes the instructions, makes the protein, oh no, turns out it's not a good protein, immune system fights it, and remembers it. Resistance against virus gained. If you want to know how your body reacts to the vaccine and develops immunity, I made a video on that too. The most well-known of these viral vector vaccines is of course Johnson & Johnson's Janssen vaccine. There are others still running in clinical trials or have been recently improved to run in some countries. Moving on, the third type is subunit vaccines. This is where things get a little more different. Instead of giving instructions for the harmless stabby coronavirus protein, subunit vaccines are like, you know what? I don't even trust you to follow the instructions yourself. Just here, I'll give it to you. Subunit refers to a portion of the protein. So in the case of COVID-19 vaccines, it would be the all-knowing, all-powerful KFC drumstick look-alike, the coronavirus spike glycoprotein. And this is your 420th reminder that this protein in the vaccine is rendered useless by the big brain scientists. So it is in fact safe. One of the subunit vaccines is made by Novavax, a company that has been in the news lately due to clinical trial success. Even though they haven't been approved for distribution yet, I wanted to include it because it provides an interesting insight into the vaccine-making process because it originates from a different process. So how is the Novavax vaccine made? You take the coronavirus spike protein. Look at that stabby part. The part that makes it able to infect us. Yeah, see it? Slap 2 proline amino acids on it. Boom, it can't infect you anymore. Hazard removed, baby diapered the coffee table. Now take your instructions for this KFC drumstick. Inject it in a baculovirus. You've trained this guy. Don't worry, they're your laboratory soldiers. Baculoviruses can't even infect humans. They infect insects. Baculovirus infects the moth cell. Shoves the instruction down the moth cell's throat. Moth cell makes diapered KFC drumstick. Scoop up the farm's proteins and package it into a vaccine. Profit. They explain their entire process on their website as well, with fancy words and aesthetic graphics, but I personally prefer my explanation. What's cool about subunit vaccines is that they've been around much longer than mRNA vaccines. In fact, in 1986, this general procedure was used to make the hepatitis B vaccines. Like the mRNA vaccines, the Novavax vaccine requires 2 doses. For its refrigeration temperatures, it is stored at around 2 to 8 degrees Celsius. Lastly, we have inactivated virus vaccines. This is the most straightforward, where you take the virus, kill it so it can't cause disease, and inject it into people. Pretty self-explanatory. There's quite a few of these inactivated virus vaccines, so let's take BBIBP Corv made by Sinopharm as our example. Special cells called vero cells, derived from kidney cells in monkeys, are engineered to crank out hundreds of SARS-CoV-2. Then the viruses are plunged into beta-propiolactone, a special chemical that clamps down on the virus's genes and deactivates them. It physically prevents the genes from being accessed by covering it, like duct taping the virus's mouth from screaming, "Make more of me!" Everything else remains the same, so the spike protein can still bully its way into the cell. But without functioning genetic material, it can't get the cell to make more viruses, so it gets digested and spit out for the immune system to find and destroy. After being treated with beta-propiolactone, the inactivated viruses are treated with some aluminum salts that actually help increase the immune response to a vaccine. It can stick to your cell membrane, shuffle around some of the lipids in it like poker cards, and that will trigger dendritic cells to secrete a signal called interleukin-1 beta. This signal screams for more antibodies to be produced, so it makes sure your immune system cells are hard at work. Now, before you go screeching, "Oh no, it's not safe, it has metals in it," keep in mind that the amount of aluminum you get just from eating food is more than the tiny bit you get from the vaccine. Your body is probably buff enough to handle it. So that's inactivated virus vaccines. At the end of the day, the different methods these vaccines use all end up with the process of building familiarity with SARS-CoV-2 in your immune system. In terms of efficacy, these vaccines vary some. The ones at the front of the line with the highest efficacy rates in the US are Moderna, Pfizer, and Johnson & Johnson. With their super speed organization and management, they have already gone through the required clinical trials and begun distributing to places in the US. In other parts of the world, there are viral vector and inactivated virus vaccines that have been approved for use as well. So regardless of which vaccine you choose to get, whether it's the new and shiny tiny fat particles with mRNA inside, the robber-turned-pizza delivery guy, the baby-diapered KFC drumstick, or just the plain vanilla SARS-CoV-2 with messed up instructions inside, the point is that it is always better to be vaccinated than not. Yes, some of the vaccines may have different efficacy rates, but there's no point waiting around to get vaccinated for a specific drug to be approved if there are already vaccinations available in your area. As long as you are sure you will not be severely affected by vaccines due to allergies or health complications. And that's all from me. Thank you guys for watching. Let me know in the comments below if I missed something or got something wrong, and I'll see you guys next time.